Sir, I have tried, but I was not get.
Question number 1G. So we will start from question number 1G, which is sec A minus 1 over sec A plus 1, and we have to prove it is equal to 1 minus cos A over 1 plus cos A. So we start with LHS equals to sec A minus 1 over sec A plus 1 equals to, now as we know that sec A equals to, what is the relationship between sec A and cos A? As we here observe that left hand side has only sec A and right hand side has cos A. So what is the relationship between sec A and cos A? So we know that sec A equals to 1 by cos A. So in place of sec A we write 1 by cos A minus 1. In denominator also 1 by cos A plus 1. So it is equal to, then if we take LCM of the denominators, it is cos A. Numerator is 1 minus cos A. And at the same time in the denominator cos A. So numerator is 1 plus cos A. So it is equal to then 1 minus cos A over cos A into cos A over 1 plus cos A. So this cos A cancelled out. Though we have to write it in vertically downward, but we can write in this with this manner also, no problem. But use equal to sign only. Okay. Hence proved. Very easy. We have to think about the relationship between sec A and cos A only. As sec A can be converted to cos A by using the square relationship. Sec A equals to 1 by cos A. So when we substitute 1 by cos A in place of sec A, we get 1 by cos A minus 1 over 1 by cos A plus 1. And when we take the LCM of denominators in the numerator, it is cos A. So 1 minus cos A over cos A whole over 1 plus cos A over cos A. So cos A cancelled out. Finally, answer is 1 minus cos A over 1 plus cos A. Then draw the line. And next doubt is in question number 2A. Question number 2A, this one. Two sec square theta minus sec to the power 4 theta. 2 sec square theta minus sec to the power 4 theta minus 2 cosec square theta plus cosec to the power 4 theta equals to cot to the power 4 theta minus 10 to the power 4 theta. First, always write the question so that you must know what to prove, and always pay attention in right hand side. What we have to bring in right hand side and what we have in left hand side. So in left hand side we have sec square theta, sec to the power 4 theta, cosec square theta and cosec to the power 4 theta. And in right hand side we have to bring cot to the power 4 theta and 10 to the power 4 theta. So first we think about the relationship between sec square theta and any one of cot theta and tan theta. So recall about the square relationship. There are three square relationships. First is sin square theta plus cos square theta equals to 1. This question has neither sin theta nor cos theta, so leave it. The second is sec square theta equals to 1 plus tan square theta. This has sec square theta and sec square theta equals to, we know that 1 plus tan square theta. So in place of sec square theta, we can write 1 plus tan square theta. And in the right hand side, we have to bring this tan theta. So sec theta can be easily converted to tan theta. Second is also sec square theta. So if we write it sec square theta whole square, or we can take sec square theta common from first two terms. So first we write LHS 2 sec square theta minus sec to the power 4 theta minus 2 cosec square theta plus cosec to the power 4 theta. If we take sec square theta common from first two terms, sec square theta into 2 minus sec square theta. And now we can convert this sec square theta to 1 plus tan square theta, as we have already discussed this. That's left hand side as sec square theta, and we have to bring tan square theta. So we can replace sec square theta with tan square theta directly by using the identity sec square theta equals to 1 plus tan square theta, which we will do in next step. And at the same time, this sec square theta, which is inside the bracket, can also be written as 1 plus tan square theta, as we have not to bring sec square theta anywhere in the right hand side. So we convert all the sec square theta to 1 plus tan square theta. Again, in the next terms, next two terms, we observe that cosec square theta is common, minus cosec square theta is common. So from first term, minus 2 cosec square theta 1 minus cos square 2 minus cosec square theta will be there. And now we will think one more thing. We have cosec square theta and we have to bring 1 tan to the power 4 theta, and tan theta we already have discussed. So other thing is cot square theta. And there is a relationship between cosec square theta and cot square theta also. We know that first square relationship is sin square theta plus cos square theta equals to 1, which is the relationship between sin theta and cos theta, and there is no sin theta and cos theta in the equation. So leave it. Second, sec square theta equals to 1 plus tan square theta, we have to use in this. And third is cosec square theta equals to 1 plus cot square theta. And we have cosec square theta and we have to bring cot square theta. So both will be used in this identity to prove. Okay. So we can use both the identities to prove it. So we write in place of sec square theta 1 plus tan square theta into 2 minus in place of sec square theta again 1 plus tan square theta minus in place of cosec square theta we will use 1 plus cot square theta into 2 minus again in place of this cosec square theta we will use 1 plus cot square theta. Okay. Nothing is wrong. Okay, then 1 plus tan square theta into in the second bracket, when we open the small bracket, minus is outside the bracket. So 2 minus 1 minus into plus minus tan square theta minus 1 plus cot square theta into 2 minus 1 minus cot square theta. So it is equal to 1 plus tan square theta into 2 minus 1, 1 minus tan square theta minus 1 plus cot square theta into 2 minus 1, 1 minus cot square theta equals to 1 plus tan square theta into 1 minus tan square theta is 1 square minus tan square theta whole square into again 1 plus cot square theta into 1 minus cot square theta, 1 square minus cot square theta whole square. So it is again 1 minus tan square theta whole square is 10 to the power 4 theta minus is also between these two brackets, this minus. minus 1 square is 1 minus cot to the power 4 theta. And when we open the bracket, 1 minus 10 to the power 4 theta minus 1 plus cot to the power 4 theta. 1 will be cancelled out. So minus 10 to the power 4 theta plus cot to the power 4 theta. So positive must be written first, and we have to bring in right hand side cot to the power 4 theta minus 10 to the power 4 theta. So cot to the power 4 theta minus 10 to the power 4 theta equals to RHS. So only thing which we must remember is what we have in left hand side and what we want to bring in right hand side. If we observe the left hand side, it has sec square theta, sec to the power 4 theta, cosec square theta, cosec to the power 4 theta. Means only two things are there. Two trigonometric ratios are there, sec theta, and it is also in all even powers. That is, we can have sec square theta, and whenever there is sec square theta, we have to keep one thing in mind, that we can use here the identity, square identity, sec square theta equals to 1 plus 10 square theta, which we have used also. And next is cosec square theta. And whenever there is cosec square theta, we have to keep in our mind that cosec square theta equals to 1 plus cot square theta. And at the same time, if we observe the right hand side, it is cot to the power 4 theta minus 10 to the power 4 theta. Means sec square theta equals to 1 plus 10 square theta. We have to bring 10 theta. And cosec square theta equals to 1 plus cot square theta. And we have to bring cot square theta also. So if we do only this, we can easily solve this question. After 2A, students have doubts in question number 2B also. When you have solved, it is slightly confusing, but it's very easy. So first we will write the question number 2B. It is tan A plus cosec B whole square, tan A plus cosec B whole square minus cot B minus sec A whole square minus cot B minus sec A whole square equals to, we have to prove 2 tan A cot B, 2 tan A cot B into cosec A plus sec B. So again the method is same. Start with LHS, write the LHS. And at the same time, when you write left hand side, you have to think about the next step. As whenever you play the chess, you have to think about the next two chances. What we will take the step in next two chances in chess. Similarly, you have to think in the proving of trigonometric identities also. So it is tan A plus cosec B whole square. We have to bring tan A cot B both. Cosec square B will be there, which can be converted to 1 plus cot square B using the identity cosec square theta equals to 1 plus cot square theta. And we have to bring cot B also. So cosec square B becomes 1 plus cot square B, and it will be obtained when we expand this. Again, cot square B is also there. We have to bring sec A, means sec square A can be converted to 1 plus tan square A, and we have to bring tan. So after thinking this, we will start the next step of the question. Means first of all, we have to use A plus B whole square in expansion of tan A plus cosec B whole square. So A is tan A and B is cosec B. So when we use a plus b whole square equals to a square plus b square plus 2ab to expand the first bracket, it becomes directly you can write 10 square a, as we know that 10a square is nothing. It is 10 a whole square. And why to waste time in writing 10 a whole square directly? You can write 10 square a as 10 a whole square is equal to 10 square a. So always remember this. Next line, 10 square a plus b square means cosec b whole square. So it can be written as cosec square b plus. Now a plus b whole square is a square plus b square plus 2ab. So 2 into a into b. So after writing this, the next bracket, before the next bracket, we have minus sign. Before next bracket, we have minus sign. So don't write this minus sign at the end of the line, as we have to write the next line. Some students write the minus in this and then start like this, quad square b, as we have to use the formula of a minus b whole square for the second bracket, which is a square plus b square minus 2ab. So they write this minus at the end of the line and then write a square plus b square minus 2 quad b sec a, and even they do not use the bracket also. We have to use bracket. Even after using the bracket, use this minus sign in front of this bracket only, as this is the sign of this whole bracket, not the sign of previous line. So it will be wrong if you apply minus sign at the end of the line at this place. So we will not use minus sign at this place. Instead, we will use it in next line, and then only one step must be done per line. So we will now expand this second bracket by multiplying minus to each term, as minus is outside the bracket. Don't forget to use bracket when there is minus sign outside the bracket. Otherwise, it will be wrong. So 10 square a plus cosec square b plus 2 tan a into cosec b minus, open the bracket, cot square b minus sec square a minus into minus, this minus outside the bracket into minus, plus 2 cot b into sec a equals to, now we know that there is a relationship between tan square a and sec square a, and it is tan square a equals to sec square a minus 1, or we can say sec square a equals to 1 plus tan square a, or we can say the original relation is sec square a equals to 1 plus tan square a. And this line has term containing tan square a as well as the term containing sec square a. So write them together first of all. Tan square a minus sec square a. Next, cosec square b, we have a relationship between cosec square b and cot square b also. Both are present in the equation. So cosec square b equals to 1 plus cot square b. So first we know that when sec square a equals to 1 plus tan square a, using this as sec square equals to 1 plus tan square a, so we can find the value of this tan square a, which is in our calculation, and sec square is transferred to right hand side, minus sec square a, and 1 is transferred to left hand side equals to minus 1. So in next line, we will write this value of tan square a minus sec square a equals to minus 1. And at the same time, cosec square b minus cot square b, we already have discussed this also, that the third square identity is cosec square b. In place of theta, if we write b, it is b equals to 1 plus cot square b. So if we transfer this cot square b to the right hand side, we get cos square b minus cot square b equals to 1. In the next line, second term will be there 2 tan A cosec B plus 2 cot B sec A. So the next line we already have discussed. First two terms are giving -1. Next two terms are giving +1. And remaining two terms are written as they are. 2 tan A cosec B plus 2 cot B sec A. And what we have to bring? First we will cancel -1 and 1. It is 0. And next two terms are written as they are. 2 tan A cosec B plus 2 cot B into sec A. Now 2 will be common. 2 we have to bring. And tan A cot B, but they have no common term as tan A cot B. But remember, if we take C common from A plus B, what will we get? Can you tell? Okay, so if we take C common, it means that we are multiplying A plus B by C. So we have to divide all the terms by C. So when we divide A by C, it is A by C plus B by C, it is B by C. Always remember, whenever we take something common, it doesn't mean that it must have a part of A. We can take any term common from the two terms, but we taking common means we are multiplying that term, like we are multiplying C to this A plus B. So if we multiply C to A plus B, then we have to divide all the terms of A plus B with C, that is A by C plus B by C. So always remember this. Whenever we take 5 common from A plus B, it will give 5 into A by 5 plus B by 5. Similarly, if we take what we have to bring 2 tan A cot B outside the bracket, means we have to take tan A cot B common. 2 is already common, 2 is in both the terms. So next line we take tan A cot B common from these two terms. So when we take tan A cot B common from these terms, first term is 2 tan A cosec B, like in this. And C is, in place of C, it is 2 tan A cot B. So if we have taken 2 tan A cot B common, it means we have to divide whole term by 2 tan A cot B. Again, plus the second term is 2 cot B sec A. So we have to divide it also by 2 tan A cot B. Means if we have taken 2 tan A cot B common, we have to divide both terms by 2 tan A cot B. So in next line, it is 2 tan A cot B, which we have to bring in right hand side. So we have brought it into 2 is cancelled out, tan A is cancelled out. And next term is, some student cancel like this. They are very happy that it has been cancelled out, but no need to cut it. It appears that it is wrong. So don't cut it. You have to cancel it without cutting. Write directly the terms which are left after cancelling of 2 to tan A means cosec B only over cot B only. This also helps you to identify your mistake if you do something wrong in solving this. So again, in next term, 2 will be cancelled out. Again, tan A will be there. Cot B is also cancelled out. If you look at this, 2 cancel, cot B cancel, but you have not to show the cancellation. Directly write the remaining terms. That is sec A over tan A. In the next line, we have to bring 2 tan A cot B outside the bracket. So write it as it is. And look at the right hand side again. We have to bring cosec A plus sec B inside the bracket. So if we change, if there is no way of solving trigonometric identity further. So we convert all of them to either sine A or to cos A. Either to sine A or to cos A. We know that cosec B can be converted to 1 by sine B. Sec A can also be converted to 1 by sec A. Means either to cos or to sine. 1 by cos. Again, cot B. Cot B can be written as cos B upon sine B. In terms of sine and cos only, means either sine B or cos B or both. In terms of sine A cos A, means tan A equals to sine A upon cos A. Cot A equals to cos A upon sine A. Cot B equals to cos B upon sine B. And at the same time, tan A equals to sine A by cos A. So this cosec B now becomes 1 by sine B, denominator. Cot B is cos B upon sine B plus sec A is 1 by cos A over tan A is sine A upon cos A equals to 2 tan A cot B into, this is now 1 by sine B into, when we divide a fraction with other fraction, the second fraction is taken as its reciprocal and they are multiplied. So 1 by sine B is the first fraction, division is changed to, means this upon means we have to divide by cos B by sine B. So first we convert it to multiply, then write the reciprocal of cos B by sine B, which is sine B by cos B. Plus again 1 upon cos A into this sine A by cos A becomes cos A by sine A. And in the next line, 2 tan A cot B into sine B will again be cancelled out. So without cancelling them, we have to write 1 by cos B plus again cos A will be cancelled out in the next term. So 1 by sine A. And what we have to bring in right hand side, we have to read it again. Cos A means 1 by sine A, sec B means 1 by cos B, and both are there. So 2 tan A cot B into 1 by cos B becomes sec B plus 1 by sine A becomes cosec A equals to RHS, hence proved. So this is the next identity which we have to prove. Tan A plus cosec B whole square minus cot B minus sec A whole square equals to 2 tan A cot B into cosec A plus sec B. First of all, use A plus B whole square to expand tan A plus cosec B whole square. Cot B minus sec A whole square is squared by using A minus B whole square. Reasons are written, so you must have understood. And then n square A plus cosec square B plus 2 tan A cosec B will be obtained from the first bracket. Minus must be written outside the bracket of which it is written already. Then next bracket is in next line, so we have to write this minus sign also in the next line. Don't write at the behind the line, otherwise it will be considered wrong. And you can do the mistake also if do this. So bracket minus cot square B plus sec square A minus 2 cot B sec A. When we open the bracket and arrange the terms which are according to the square identity, sec square equals to 1 plus tan square A, we get tan square A minus sec square A equals to minus 1. So we write tan square A minus sec square A together, which will be replaced by minus 1 in the next line. And at the same time, cosec square B minus cot square B are written together, which will give 1 in the next line. We will write 1. And the remaining two terms will be written as they are. Now minus 1 plus 1 will be cancelled out. Remaining two terms are again written as they are. Now we have to bring 2 tan A cot B common from the next term. So when we take common 2 tan A cot B, so remember, whenever there is nothing common, but we are taking it common. So taking common is nothing, but it is equal to dividing and multiply something. First we multiply C, and so we divide all the terms by C. So if we take C common from A plus B, we have to divide both the terms by C, A by C plus B by C. So 2 tan A cot B into 2 tan A cosec B is the first term which will be divided by 2 tan A cot B plus 2 cot B sec A is the next term which will be divided by 2 tan A cot B. So it is equal to again 2 tan A cot B into cosec B over cot B as 2 tan A cancelled out from the first inside the bracket and 2 cancelled out, cot B cancelled out from the second term. So it is sec A by tan A. Now change them either to sin A or cos A or sin B or cos B. And we know that cosec B equals 1 by sin B. So in place of cosec B, we write 1 by sin B. Cot B equals to cos B by sin B. So in place of cot B, we write cos B by sin B. Plus sec A, so in place of sec A, we write 1 by cos A over in place of tan A, we write sin A by cos A. So it is equal to 2 tan A cot B into sin B cancelled out. 1 by cos B plus 1 by sin A, 1 by cos B sec B, 1 by sin A is cosec A. This is what we have to bring in right hand side. Always pay attention what is right hand side so that you can solve the question easily. So this is the solution of question number 2B from the sheet.